From Undead Labs, and we're really excited that he's taking the time because he's supposed to be at an event over at Microsoft, and he's like, oh, I'll go after I talk to the students. So ask him lots of good questions.
I think you can just put that down.
Okay, yeah, you can talk better.
I think so. I mean, if anyone has trouble hearing me, let me know and I will pick up the microphone. I don't actually see, where's my field of view here? Okay. I gotta get to the laptop, there we go. Hi, thank you everyone for coming. You know, this is a big crowd. I mean, you're kind of hard to I think to give a talk to because you're such a broad audience. You have so many different things you care about and that you want to learn about. So I'm just going to apologize in advance for what I'm going to talk about because this is just, you know, what I care about. And so I get to make you my captive audience. I have speaker notes and I'm kind of on the fence on whether or not I want to use them. I feel like sometimes just writing them is half the battle. So I guess, like was said, I work for Undead Labs. Undead Labs is based here in Seattle. We're in Pioneer Square, so pretty close to here. We're about 70 people. I am not from here. I came here from Norway 9 years ago at this point. Your lutefisk kind of sucks, but otherwise it's a good country to be in here. Yeah, I've lived in the Seattle area for 6 years. I've not been in the games industry for my entire career. I was told by many people that the games industry was not a good place to go because I think it has had a reputation of being kind of crunchy and an unhealthy work environment. Eventually I decided that I wanted to follow my dreams and do that, and I've never had that problem, and so it's obviously not as bad as people make it out to be, but it is something to be mindful of, I think. Don't let people take advantage of you. I've done kind of a broad spectrum of stuff in the games industry, and adjacently. I've always been a programmer for longer than I've been going to schools, and so what I've done on these projects is mostly anything that is code related. I'm pretty flexible on that front. I'm happy to talk about anything that I've done, or anything about me, or anything about my career, or anything about any projects I've been involved with as a part of this. At the end, if you have any questions, you can ask me whatever you want. I might say I'm not going to answer that, but you can at least ask. These slides and all my contact information are going to be, all my contact information is going to be on the last slide, and the slides will be online probably tomorrow. Just trying to think about when I'm going to sit down at a computer again, but yeah, so you can get that information whenever you want to. Right now at Undead Labs, I do a lot of different stuff. It is just, my philosophy has always been figure out what needs doing the most and do that. Sometimes that means I work on stuff that I don't enjoy working on from kind of a pure programming perspective, but it is something that benefits the company or the game or my peers. And as a part of that, something I do enjoy is kind of low-level programming, and so for the past 3 years I've been a contributor to the Unreal Engine on GitHub. It's kind of a perk of the work that I do is that since we're using Unreal Engine at work, I get to be a part of that community and participate in that. So the most recent game we made is called State of Decay 2. It was originally State of Decay 2 is a Undead Labs title, like that's what we made. We were published by Microsoft, but as of July of this year, we are now a wholly owned subsidiary of Microsoft, is the full phrase. So we're part of the Microsoft family, but we're still pretty independent. We're 70 people who are in Pioneer Square by ourselves, and we do what we care about. The game came out half a year ago, which is to say that if you had asked me to give a talk 6 months ago, I would not have been able to, because it was pretty hectic getting that out the door. It's been a game that's been in development for quite a while, yeah, and so for those of you who have not played it, it's a Xbox and PC third-person zombie survival fantasy game where you manage a community to, survive after the apocalypse. We consider ourselves to be double A or triple I. This is weird phrases that the industry use, but like since we're only 70 people, and that's what we grew to by the time we shipped the game, we're kind of a smaller studio than like Bungie, who's like 500 plus people or things like that. But we're not exactly indie anymore either. I've been able to work on a project that had 4 million unique players, more. I had to revise that number because this is the latest number we published, and that's what I'm going to stick with. Yeah, like I said, it was kind of a lengthy development, and it was, I think it was nearly 5 years from when they started until we shipped. I was a part of 2.5 of those, yeah, it was a lot of people who cared a lot about that game, and from 30 people to 70 by the time it came out, and so that's where we are right now. And it's probably going to get a little bit bigger because we're working on new exciting things, and 70 people is can get you State of Decay 2, but if you want more than that, you're probably going to need more people. So I talked a little bit about Unreal Engine, which is what we shipped the game on. As a game developer, I want to say that if you can avoid doing some work, and using an existing engine is a huge boon in that regard. Like, you get so many tools and so much community effort for free. State of Decay 1, which came out, I guess 5 years ago, but don't fact check me, or do and then don't tell me afterwards. Came out on CryEngine. I think it's a German company that makes CryEngine, and by the end of the development, I think it was clear to everyone involved that we could not make another game on CryEngine that was bigger than the first game. And so we ended up shipping State of Decay 2 on Unreal Engine 4. But the interesting thing is that there have been 3 engines that we've had a State of Decay game on, and that was because when we switched from CryEngine, we switched to something called BitSquid, which is kind of a small engine that now is called Stingray, and it's owned by Autodesk. I think the programmers really loved that engine. They were super excited about working on that engine, and nobody else was. Which I think they put about 2 years into development, and so it was a fully functional game on BitSquid at the point where we realized we could not make the kind of fidelity and breadth of the world that we wanted to on that engine. And so I think it was one of the harder decisions that were made in the process of making that game was switching engines. And it was a whole studio effort where everybody got to vote and have an opinion, and it was a lot of debating about it. And they decided that Unreal Engine was in fact where they wanted to go. And I came in right afterwards, so I did not have to be a part of that hard decision, lucky as I am. And but I think the thing that made that even harder was that, we had all this work we now needed to redo, but it wasn't as if we magically had more money, and so we still needed to ship a game in the same intended timeline, but now we had to redo a lot of it. And so it definitely influenced kind of where development went for the last 2.5 years. And so State of Decay is a large open world, like a large open world game with a lot of different systems involved. Like it's a... Oh, you have a question?
Yeah, just real quick. Pretty much every developer I've talked to has mentioned like a big hurdle or a big decision during the development of the game, and often pretty late into it. Like the Kaleidowalk story is full of all these sudden complete overhauls. Would you say that we as game developers should expect to have to scrap or recreate or otherwise make big decisions that might affect our launch times regularly?
I think you would be happier if you did, because you would put bigger margins in your process and in your scheduling. I think you also, if you are prepared to scrap anything you work on, you have less of an unhealthy attachment to the product that you're making. I think a lot of, there's a number of bad game design decisions or game decisions that are made because people have a hard time letting go of something they've created. And I think that's something that you kind of learn over time, but you have to know when you're simply fighting because you created it and because you have put all your love and effort into it, versus when it actually needs to stay for a good reason. And but game development scheduling is an unsolved problem, and the more critical you are about that when you start, the better off you're going to be. You know, like, it's always better to assume something's going to take longer, because if you under promise and over deliver, right? Like, that's easier to work with. Yep. But I have worked on projects where we have not made huge decisions to change everything halfway through, so it's not a law. It's just a relatively common occurrence. But yeah, and so in terms of an open world game, there's a lot of different systems, and so in State of Decay we have a rich world of non-player characters, of zombies, of interesting things to see and do. There's a lot of loot to find. We try to make a rich tapestry, basically, where there's so many different things that kind of influence your everyday interaction with the game, but that also means that there's a lot of dependencies between them, where you can't easily pull them out a lot of the time, especially if you're not intentional about it. And so one thing that I saw happen was that we had this kind of reliance on what I will generously call magic, which is that there was an assumption that the problem we were seeing was going to be solved down the road because we had this other thing coming in. We were going to implement some system, and once that was in, we wouldn't have this problem anymore. But it's kind of I think it's easy to get into that mode, and I'm not blaming anyone for being there. The particular system that I worked on that had this problem was we have a lot of missions in the game. Like, there's a lot of different kind of goals that the player is trying to achieve, and we hadn't thought about how to pace those, like how those, the player can run around the world and do whatever they want, and we didn't really put a lot of thought into the specifics of how we're going to pace it, and how often they got missions and what kind of missions we gave them. We just kind of authored a lot of content because we had this idea of this, we called the story director, which was a simple kind of AI system that was going to look at the entire world, look at your community, look at what you've been doing as a player, and make decisions based on like dramatic pacing and your community's need and kind of what you were interested in doing. And since whenever that question came up, like, oh, how are we going to set, like, the pacing feels off, what do we do about this? We would always say, well, once we get all the missions in, we'll look at the story director and we'll tune it and it'll be fine. The problem was that tuning the story director was basically a magic black box. You said things like, say that drama should be 3 times more important than food, and also, say that danger should be, half as important as food. And then you couldn't really tell easily without playing hours and hours of the game what that actually meant. And so that was a hugely unsustainable way of kind of being like having control. Like, we had very little control, which is dangerous when you're shipping a game, because you don't know, like, if half your audience is going to have bad experience, you're really messed up. And so kind of towards the end of the process, we decided to axe that whole story director system, and we said, cool, what if we instead just did a deck of cards and we just deal cards? And then we're like, cool, that's done. It was obviously not that trivial, because now we had all this pacing work that we'd been punting on for the whole time that we had to do afterwards, but it got us into a much better place to ship. And like I talked about, there's a lot of scope problems with open world games specifically, because they tend to have a lot of, like, a platformer is usually straightforward. You know what challenges you're meeting, you know what tools the player has, you expect them to go from left to right, you expect them to play this level after that level. But in an open world game, we have, I think they're roughly 16 square kilometer maps, and the entire map is just filled with buildings, and they can go wherever they want to, and we need to try to kind of feed into that. And so we have like 500 missions in the game, but those aren't missions in the sense of like you do one and then the other and you do 500 of those. We'll randomly give those out, and each of them will be randomized based on where you are, where the mission takes place, where you're going, what you're doing. Like, are you getting a weapon or are you getting a backpack? What person you're talking to. It could be somebody that you've talked to for another mission. It could be a completely new person who comes into the world for that mission. All these variables that kind of feed into it, and that means that it's really tough to kind of say what is the full set of possible player actions, right? Because they could play mission 1 and then 2 and then 3, or they could play mission 3, 2, and 1, or they could play 1, 2, and 3, but in a completely different part of the map. And so when you say, like, hey, can you go test this game, for example, you can, like, there's, like, you could play it for 100 hours and still not have tested every part of the game, because there's so much of it. And the other part of it is, I mentioned the size of the world, and so we have 3 maps that are each roughly 16 square kilometers, and that are hand modeled and put together with lots and lots of interesting houses and second stories and, you know, little military outposts and, you know, little mountains and everything. And there's just so many places where anything could have gone wrong, like any part of this. It could be that we let a player vault, because we have a mechanic where you go up to some edge and they will just kind of pull themselves up on it. Problems we've had is, well, there was a bug where one place in the world somebody ran up to a fence and they jumped over and the other side was a cliff and they dropped down to their death. And then you're like, well, shucks. And you can't just say, hey, you know, our QA team of like 6 people, can you please go through every part of the entire world? Because that's like, you know, weeks of work just doing that. And that doesn't take into account, like, where are the vehicles parked, where are the zombies, are you fighting, you know, like all these different permutations. And so it's kind of an overwhelming problem space in that sense. And so a lot of it too was we had weird things where just the AI would fall through the ground in one particular spot in the map. They would just like walk over and then they would be like, cool, I'm just gonna lower myself through the ground and then disappear into the void. And we're like, what the? And so there's a lot of interesting problems, but they're all about kind of the scope of it. And like I mentioned, we generate a lot of characters, and every mission and every character in the game is procedurally generated to some degree or another. And so we have this massive system of traits. This is how we generate a character to present to you. And each character will maybe have 4 or 5 traits assigned to them, and they will have a cultural background, and that's where we choose the names from. And there's like 8,000 names, and then there's like another 7,000 nicknames, and then there's, you know, 1,300 traits that we kind of randomly pick from to combine into interesting characters. And the traits could be stuff like, used to work at a grocery store, or, you know, was a doctor, or, you know, was holed up at a gun range for the first 3 months after the outbreak, or, you know, has a cataract. You know, there's all these things that tell stories about the characters, but they also influence how the characters present in the world and what kind of skills they have. And I'm not even going to do the math because this is very simplified. We have a lot of rules for how those can be combined, but there's just an enormous amount of potential characters, and some of them are completely broken. Like, and we write a bunch of rules to try to prevent that, but we can't even test if our rules are doing the right thing exhaustively because there are so many different potential options. And it'll be subtle things like, this person gives you positive beds. He has a trait that means he can sleep on the floor, so we reduce the number of beds he takes. But then he has another trait that does the same thing, and now he suddenly takes -1 beds. And then that means that some other person in the community doesn't need a bed anymore because this person sleeps on the floor very much. And it's like, this makes no sense. So there's a lot of subtlety that comes with it. And there's also like balancing concerns. Like, don't get me started, I'm sure there are some designers here. Like, imagine trying to balance these things where each of these trait has a mechanical impact on the world, and there are complex rules about which ones are allowed to be combined. And then you're just like, hopefully this isn't bad. And yeah. So let's talk about a little bit more about how we kind of address that, or try to address some of these things, because it's not hopeless, it's just complicated. And some of these things are kind of more ideals that we want to pursue more in the future because, like I said, we switched engines halfway through the development, and so there was a lot of work that had to be redone, which meant that we didn't have as much time to develop our tools as we wanted to, for example. This is, I think, Jeff Strain, the owner of Undead Labs, loves to say this. But it's basically the idea that you start with a core of a game that works all on its own. And whenever you add anything, you add it in a way that it only relies on what's already there. Because we have these problems with these kind of like open wounds, like the story director, where it's you have the assumption that a separate system is going to come in and solve the problem for you, but then you end up cutting that feature. And then you're like, well, shit. Like, you understand that you're cutting it because, you know, there's budget and time constraints and you have to ship a game. But you can't consider every impact that a cut has. Sometimes you just have to make a decision, and it sucks. And so when you cut something, you want to make sure that it has as little impact on what you've already done as possible. Because if you have to scramble to fix up things that you've already done, then you're not really reducing the scope. You're just kind of slightly offsetting. And so starting with a core and then kind of slowly layering on more systems that are always self-contained with what's there helps you avoid that situation. The other part is that you really don't want people to do all the work because people are expensive and slow, me included. The more you can have the computer solve your problems for you, the better it is. And this isn't all just like automated testing or unit testing or whatever. It's the entire kind of focus you have on tooling. And so for how we do this in State of Decay, things like telling a designer that the data he entered or she entered is going to be a problem immediately is way better than a QA tester finding it maybe 3 weeks from now. Because then people have to get back in the mindset of what they were doing previously, and there's a huge maybe, because like nobody's perfect, and so the QA might not catch the problem that you've introduced. And so like giving immediate feedback and doing it automatically without any person involved having to do anything means that you're going to catch a lot more. We have nightly content checkers that looks at the entire map and says, like, here's some geometry that's like inside some other geometry. You probably rescaled something and something is wrong, but if the player sees this, it's going to be really bad. Or there's a hole in the ground here, and I don't mean that from the perspective of somebody has dug it, but there's no geometry there and you're just going to fall through. And so having tools that can detect that for us saves, you know, man-years of effort. Go ahead.
Do you build a lot of those tools while you're in development, or do you get some before after?
I think that depends a little bit where you're coming from. If you're starting a new game that you've not built before, it's not a sequel, it's not, you know, similar to something you've done, I think you're realistically going to build it all as you're building the game because you don't know what you need. And I think most of these tools, except for the most basic ones, require a pretty deep understanding of what you're making. And so if what you're making is, you're likely the first person to do that in that specific way, right? Like even if it's, you know, even if you're making Pong, you're probably making Pong in a different way than somebody else has. And so you're not going to be able to rely on a lot of pre-made stuff, and it's going to be really hard to plan out for it. And if you do plan, you're probably going to be wrong, so you're going to do a bunch of work you're going to have to throw away. So realistically, I think as you develop, you just need to kind of set aside a part of your time estimation to be tool support, and that could be, you know, for your quality assurance department. It can be for your, you know, fellow artists. It can be for for other programmers. Like it's just about like setting aside the time for it, so you do actually do it at some point. Yeah, and the other thing, like when it comes to tools, is I think that unless you think, my opinion is that unless you think thoroughly about what you're doing when you're making a tool, you're going to make it in a way that's going to be almost as harmful as it is helpful. And I do this all the time, because a lot of the time I'm like, I'm just going to throw something together quickly for a designer or for an artist and whatever, just going to get it out there. And then I realized I gave them a text field where they were going to type in the name of some animation. What happens when they mistype that animation name? Because they've typed it like 6 times today, and like they're just slamming it in and like whatever. And you're like, cool, so now my system has to make sure that doesn't crash at runtime or that does the right thing, but how do we know that it was bad? And so the less opportunity there is to make a mistake, the less mistakes there are. It sounds obvious, but it's a thing that people don't think about when they make tools a lot. And so what we try to do is, if there are wrong values for your field, you should not be allowed to type in it. Like, that is just, if there's a value that's not valid, then you can't type. It should be a drop-down, it should be, you know, a number or a slider or whatever, but it should not, anything you can type into there should be valid. And the same thing, we have a custom in-house data editor that we use that has a lot of validation logic, and it's how we author missions, names, traits, like zombie siege waves, ton of different things, and it has built-in validation support where we can say, like, okay, you typed this thing in and it's a bad thing, you should feel that. So now we try to tell you when you hit save. So when you hit save, we say you should feel bad. I don't use those words because I'm not a jerk most of the time, after coffee at least. But it is important to like make that so that there's not like a manual step where somebody has to say, I want to check this for errors. It should be checked for errors when you make it. And so reducing the amount of potential errors is good. The other thing is sometimes you make something into, you like put something into your game and you're like, this shouldn't happen, but it could. And if it does, that's bad. And I think it's obviously not for a student project. This is probably not kind of the scope you're talking about. But having an infrastructure for error reporting, there's a lot of like existing solutions you can use. We use something called Rollbar at Undead Labs. It's a little indie company that makes it. It's an error reporting solution where your game can send an error message up to the internet, and then we can see them. But it's really important to, if you use anything like that, to make sure that it's an actionable thing. When you, as a developer, see an error report from anyone who's played your game, you want to be able to look at that and say, oh, I know what's wrong and I know what to do to fix it. Because otherwise you end up with a flood of them. I've seen that happen where you just have this huge backlog of problems, but nobody knows how to solve them, or it's going to take a lot of work to figure out how to solve them, and then they just languish forever. And nobody really wants that. And if you're a designer, just plug your ears a little bit. You really need to put hard limits on everything in your game. Designers love to have open-ended systems where it's like, I can make this do anything. Whenever you can make something do anything, it's only going to work for like a very small subset of that because that's what it was tested with or implemented for. And you can always change a hard limit. Like you can say, we will never spawn more than 8 zombies. Just set that into your code or into your system or whatever. If you're a designer, the stack size of this thing is 8. That's just what it's going to be. When you set down a hard limit, and then you get to a point where you're like, okay, this is a bad hard limit. You're like, I actually need 50 zombies because this should be a horror game and not like, a bad day at the mall. And so that's kind of like, at that moment, you can revisit that decision and you can be intentional about how you change it. But if you have a hard limit in there, you can also say things like, we're never going to show more than 8 zombies on the screen at a time because literally the game won't do it. And then you know that that's the case, and you can tell an artist, for example, you can put this much complexity into it, because if you can show 8 of them on the screen at the same time and the game doesn't just die, then we're fine. Like, that's kind of like, and this is the same thing when it comes back to the question of beds, right? We could say a person should never take negative beds. We should have said a person can never take negative beds. And that would have avoided that whole problem, or we could have had error reporting when it happened. But instead, we got a screenshot from a user after the game shipped. And that's not the best way to handle your errors. And so I would highly recommend, if you can, just put your foot down, make up a number. So my next slide is basically my last slide. It's going to be, I'm going to talk a little bit about multiplayer and cross-platform testing and like kind of problems we had around that and how, like what my personal opinions are on how to solve that. We can skip that and go right to Q&A, then you get like 25 minutes. What do people care about cross-platform and multiplayer? Raise your hand.
Yes.
Okay, let's keep going. So for context, State of Decay is a multiplayer game. It has up to 4 players in a session. It's not, Fortnite or whatever. Thank God. I mean, I would be really rich though, so I don't know. But that was kind of one of the things that were important to us about State of Decay 2 as compared to State of Decay 1 was that we wanted to make a multiplayer game. We wanted to make State of Decay but with friends. It turns out that it is challenging to make the game you've already made twice now because you made it on 2 engines in half the time and new systems and multiplayer. That's actually a surprisingly tall order. I don't know if anyone thought about it, but it was the case. And testing is a huge problem in multiplayer, and I know that from my personal experience of making small, shitty prototype games that if you go to my blog, you can actually still see screenshots of them, and you can laugh at me. And up until, like, you know, working on Dota 2 or working on State of Decay 2, like, large production efforts, it's always, like, one of the harder aspects of game programming. Which is why it's always funny when people on Reddit are like, oh no, they should just add, like, multiplayer to that game. It would be, like, 3 months. I'm like, 3 months in what army? Like, that's not how it works. And in order to actually make a game that has multiplayer that actually works, you need to really embrace the fact that your game is multiplayer. You need to stop testing it in single player. Because you need to make sure that you're always, all the time, playing your game in multiplayer. And you need to, when you're developing anything, you need to think about how it works in multiplayer and, you know, how it can be abused in multiplayer. One of the problems is that you're testing multiplayer locally between you and your friend or your coworker, and you're like on 100 megabit or gigabit connection between each other, and then somebody's at home and they have like a radar dish that kind of points towards the satellite, and there's like snowing and everything is bad, and turns out that's nothing like your network connection. And we use Unreal Engine. Unreal Engine has a built-in network simulation layer where you can just say, hey, cool, pretend like this is an average user, like a crappy cable connection in the middle of nowhere. And it will actually do that for you. And it turns out that when you turn that on all the time, you think about those problems a lot more than if you only turn it on when QA is doing work. Which we did. We got a lot of complaints because people were like, man, our game is not playing well in multiplayer. What did we do? And we're like, we just pretended like you're an actual person and not a developer. And and so that gives you kind of the ability to focus on that. And so that's the same thing with playing multiplayer all the time. It kind of exposes all the problems that you didn't realize were there. The other thing, and this is the thing that we didn't actually solve, which is that you need to make it easy to test multiplayer. Like, one of the problems that we have is that some of the middleware we use doesn't work super well with Unreal Engine in certain specific scenarios, and so the easiest way to test multiplayer also doesn't give you any UI, which is just a little bit frustrating. Like, it's not a great experience to test with. But that means that the friction for actually testing how people experience your game is much higher, and making sure that the fast and easy, like, load times and how many button presses you have to press to get into a multiplayer game. Like, it could be simple stuff like make sure that your game has a command line switch to join a multiplayer game, because the faster you can make it to get into multiplayer, the more likely people are to actually do it. And then from a more design perspective, one of the problems we struggle with is agency versus isolation, is how I summed it up in a very cryptic manner. But these slides have speaker notes when you download them, so you don't have to rely on my cryptic phrasing. When I say agency, I talk about when somebody joins your game, like when somebody's playing with you in multiplayer, how can they impact the world? Like, what are their verbs, what is the damage they can do, which is really what we're thinking about. Like, because our game has multiplayer, but it also has matchmaking, and so you can say, I need help from someone, and somebody can say, I want to volunteer and I want to go help somebody who needs help. And you could meet some guy who's just had a really shitty day at work, and he's just feeling really angry, and he wants to just see how much damage he can do to your game. Like, we can't fix that. Like, that's people. Everybody has a bad day. And so isolation is how we isolate you from those bad behaviors. But by isolating you from those bad behaviors, we're giving that person less agency. They're able to have less say in what happens in the world. And people play video games for agency a lot of the time, I think. Like, it's like power fantasies and stuff like that is all about agency. Like, what can you do? And so when you play with your friends, it's mostly fine. Like, if I knew you were only going to play with people you met in person, that tends to be a barrier to being a certain type of asshole. Because, like, they could just show up on your door and be like, what the fuck? Really sorry about my language. I was really thinking I was going to be super not swearing today, and then it went downhill real fast.
I'm going to take back that coffee.
It's fair. But yeah, and so, like, one of the things we had was, we used to have this mechanic that was, when you're in the world and you point your gun at someone, they're gonna be like, hey dude, what's going on, man? And then, you know, you kept doing that for long enough, he's like, stop it, just walk away. And then if you didn't, they would like pull up their gun and start shooting at you. And that was great, until some guy on the internet comes up and he goes through this enclave of NPCs that you're doing this like really elaborate arc with because you want to recruit one of their surgeons to come join your community. And then this dude just goes, points his gun in somebody's face, and you're like, wait, no, don't do that. And then the whole arc is canceled because now they hate you. So that was an unfortunate side effect of that system. And we actually decided to step back on that. Like, we didn't want that mechanic to be so destructive, because even if you, like, there's a lot of zombies in our world, and if a zombie's standing right behind somebody, it sucks if you're aiming at that zombie and the dude goes, wait, and you're like, no, that guy behind you, don't worry about it, right? Like, and so we decided that it was more harm than it was benefit, and so we dialed that back in order to, you know, give you more isolation, less agency. It's a really difficult, I think, thing to decide on, and in our game too, there's a lot of mission objectives. Like, we ask you, for example, to go pick up some loot. What if somebody else goes to pick up that loot? What if they pick up that loot and then they disconnect? Like, that's not fun. Like, then that item is gone and you can't complete that mission because you needed to bring that, you know, awesome World War II rifle back to these people who had lost it or whatever. And so it's like a constant struggle, I think. And in my personal opinion, I think we ended too far away from agency because we have a really hard time determining intent for players. Like, are they there because they're your best friend, or are they there because they're some guy from the internet? But that's a constant struggle. Any multiplayer questions before, you can take them at the end too, but before I go on. So, we shipped on 2 platforms. We shipped on PC and Xbox One. One important thing of that is that every single person at the studio, no matter what they do, has an Xbox One on their desk. Like, it doesn't matter if you're a writer or a producer or a programmer, everybody has at least one Xbox on their desk. Some people have stacks, it's obscene, but most people have one. And the reason for that is because if you're trying to ship on that platform, you need people to actually play on that platform. And one of those problems, I think everybody's familiar with kind of the bad console port experience of playing a video game. Comes up a lot when somebody ships a game and then later on some other studio takes that title and tries to port it to a console, or the other way around, and they don't do a good job. But it turns out that you're just as susceptible to that if you're doing it in-house at the same time, because the main problem isn't that it's hard to make UI or input for one platform. It's that you can only make it good if you're actually iterating on it and looking at it and experiencing it and refining it. And if people are only testing on one platform, you're not going to learn kind of where your rough spot edges are. And that was one of the problems we had earlier on, was that even when we played on PC, we played with Xbox controllers. And so a lot of our keyboard and mouse input was not as refined as it was for other platforms, because you spend so much time and it seems fine, and nobody's really looking at it. And if somebody is looking at it, it doesn't get the same weight, because it's just coming from one person as opposed to like everybody being like, we had a playtest on Friday and just, we can't even. Like, if that happens, then you know, but if it's one person, then it doesn't carry the same weight. And so, and the problems here are like, they sound kind of mundane, and UI is always one of those things that's like, it sounds simple, but it's always really complicated, because it's just, you have to match a very specific expectation that the player has, and it carries over from games to games, from platform to platform. Like, people have played PC games, they have a certain expectation of what the left mouse button does. But it's like you have to assume, you both have to educate users who don't have those built-in expectations, and you have to meet those expectations for people that have them. Otherwise, it feels rough. And so it's stuff like, how do you go back from a menu? It's like, okay, on the controller you press B. On a keyboard you probably press escape, and then you probably also need a button because you want to be able to do it with a mouse. And then you're like, okay, do you put a little X in the corner, or do you put like a back button? And like, do you have the back button there when you're playing on Xbox, or do you only show it for PC? And like, it's these things kind of like balloon out of become like huge orders of magnitude bigger than you thought they were going to be. But then there's all the other stuff, like on the Xbox controller, there's, I don't know if you know, but there's a little menu button, like a little, just bring up the game menu, like in the game. One of the things we did was like, okay, just map that to escape. Like, you hit escape, you get up the pause menu, you hit start button, you get the pause menu. That makes sense. Problem is, player expectation is that when you hit that button, no matter where you are, you get the pause menu. On PC, if you hit escape, you don't want to bring up the pause menu from wherever you are. People expect that to go back one level. And so then you have these like mismatched where B is only escape if you have a menu open, but otherwise it's the same as the hamburger menu on the Xbox controller. The only way to figure all that stuff out is by actually using your UI and spending a lot of time, or also paying really talented UX people. We did that. I can totally recommend it. Recruiting other students who are good at UX. And the final bullet point for today, performance, how well your game runs. In some ways, supporting Xbox is great because, I'm going to go a step further. If I could, I would only ship on consoles. I would ship on no other platform than consoles. And the reason for that is that you know exactly what people are going to run your game on. An Xbox is always an Xbox. Now you have an Xbox One X, but those are two things that you have to support. If you support PC, I bet that, okay, maybe in this audience not so much, but for most people, you can give them two graphics card numbers, and they wouldn't be able to tell you which one was faster than the other, right? Because it's not even about the number. It's complicated, and like a 1080 versus a 2060 or whatever, or the 1080 is faster, but only for some things, and that's what you deal with when you support PC, because you have such a broad range of different configurations. There's is it an Intel or an AMD CPU? How fast is it? How many cores does it have? How well does your game run on multiple cores? What kind of graphics card do you have? How fast is your hard drive? How much memory do you have? Is it an SSD or a spinning platter drive? And then you're like, what is the worst thing that we're going to support, and how are people going to know that they're running it on the worst thing? It's really, really hard. And there's a reason Steam doesn't do any requirements checking when you install a game, because it's such a hard problem to solve. And so shipping on consoles is good because it gives you kind of a target, and you can target an Xbox One, and you can say this is the worst requirement that we're willing to support, and then you can test on that, and you kind of know what it's like. But when you're a developer, you want a really fast computer, because running Unreal Engine's editor on a slow computer is not very fun. Compiling code on a slow computer is not a lot of fun. If Maya starts chugging, that's no fun. You want just a really beefy computer, which is not how your players are going to experience your game. And so it has the exact same problem that multiplayer does and input and UI does, which is that the things that people notice are the things that people are experiencing is the things that are going to get fixed. And so when we started being more aggressive about how we did multiplayer testing, we were like, okay, now everybody's going to be playing on Xbox One, is also when we found some of our worst performing scenarios, because everybody had been testing on these really beefy computers, and it turns out in 4-player multiplayer networking on an Xbox One, the performance was really, really bad. People were like, this is unplayable. And until you get to that moment where that is an experience that people can share and have, you don't actually know that that's a problem. But we figured it out before we shipped, which was good. But it would have been a lot less stressful if we'd done this all along. We'd always been testing on low-end computers. We'd always been testing in multiplayer. We wouldn't have like a scramble at the end to kind of make sure that we buttoned up all those parts of it. That's, I think, what I have. Here is my final slide. This is my very personal email address. It's my very personal Twitter account. It's my very personal blog, mostly old and unmaintained, but I will post some slides on this blog. So if you want to take a note of anything, you can put down that address. My DMs are open. My email is open. If you have any questions at all about anything you think it could be suitable to answer, you can reach out to me and ask. I might tell you that I'm not gonna, that I don't have the time or that I'm not able to or whatever, but I welcome anyone to ask. Doesn't even have to be programming related, whatever you feel like. So I worked on the Mac OS.
Can you repeat that question?
Oh, sorry. The question was, what work did I do on Dota 2? And the answer is I worked on the Mac and Linux ports for it. Mostly engine work and low-level stuff, SDL2.
You said you worked in NVIDIA for a little while. Can you tell us about that?
Yeah, so question was that I worked on NVIDIA, and we'll talk about that. So I worked on the Linux graphics driver. So it was a small team of maybe 10 or 12 people inside a 6,000 or 7,000 person organization. It was just extremely interesting work in an aspect of the organization that was not very loved. This was before Android had really, really taken off, and so the fact that Android was Linux, made a difference for the team, but at that time, not so much. It's a great learning experience. A lot of just low-level graphics driver bugs and weird stuff, like why is this pixel the wrong color kind of things, which if you have a deep interest in how graphics programming works, is super interesting, and for everybody else is like, why are you doing that for a living? So.
Obviously the name Undead Labs relates to the zombie games and State of Decay. Do you guys exclusively make that kind of themed games? Are you guys going to make any more horror-themed games in the future? Or anything else?
I think Matt Booty has talked about what we're doing in the future, but I don't think we've said anything about what we're doing in the future. There was a game that was being developed by the studio between State of Decay 1 and State of Decay 2 that I wasn't involved with, but my understanding is it was a little bit like Pokemon-esque. Like there was a lot of cute creatures and training and leveling and RPG elements and stuff like that. That was a mobile game that was in development. And so it's not, as a studio, I think Undead Labs is a handy label for what we're doing right now. Whether we would do other things, is up for debate, and if we did, we could do it under that name. Those are, yeah. Go ahead. Sorry, could you repeat that a little bit?
What was your favorite part of the
So my favorite part of development, it's a good question. I'm kind of a product-focused person, and so my favorite parts are the parts that impact the most people or that have the biggest impact on people. And so after we shipped, I've been trawling Reddit because there's a fan Reddit for our game, and fixing a bug just quietly, having it ship, and then having a person be really excited about that bug being fixed is one of those weird oh, that drip is so good, just give me more of that. I just want to make that amazing game. So yeah, but I don't know. I don't really hate any part of it. Oh, everybody. But let's start there.
How long, after the game shipped, do you look at bugs that people are submitting to you and actually fix those bugs?
Are we still recording, by the way, just to check? Okay. No, I think that's depends on your game. It depends on your style of game. It depends on how much money you're making, to be perfectly frank, right? there's a trade-off. Like as a developer, I want to do this forever. Like I want to make sure that nobody has anything bad to say about this thing that I've poured like years of my life into. But you know, if the game is still making money, that's a good incentive to keep doing it. The other thing is like you want your fans to trust you and to be able to, like when they see your products, you want them to have a certain like positive association, and so that feeds into it too. Like you want to kind of build that relationship. And I think it depends on kind of the severity of the bugs too. Like if it's a small minor gameplay glitch versus somebody can't play the game at all, you might come back to fix the latter but not the former. And so yeah, we're still actively developing DLC, but we're also developing just like bug fixes and patches for the game still, and so that's probably going to go on for a while.
What was like one of the interestingest bugs besides the bed bug?
The bed bug is a good name though. That's like hard to say off the top of my head. I think a lot of the stuff that I do is just like in one ear and out the other. Like I solve a problem and then I move on. So sometimes it's hard to remember. For Dota 2, I fixed a bug in the Intel graphics driver once for our game because I worked around it, where the game would randomly crash sometimes when we used some shaders, and this was for Mac, and so since driver updates for Mac are kind of sparse, they happen when the OS updates, there was no way for Intel to release a new version of the driver, and so we worked around it in our game, which was, that's an interesting way to go.
So, John, when you're moving between different projects, like from graphics to Dota to the game or to this game, what were the biggest challenges, if any, of like kind of switching? Because it seems like these are very different jobs.
Yeah, I mean, for me, I think the hardest part is just that there's a kind of an assimilation stage at the beginning whenever I come into a new project where I need to learn everything that's happened so far, or try to get an understanding for how everything fits together. Most of the projects I've worked on have been on different engines, so there's been a lot of learning from that, just like Unreal Engine, Source Engine, Planetary Annihilation had their own engine, Unity, and I feel like I'm missing something, but yeah, and so there's always kind of this getting your bearings kind of moment to it. But I love learning things, and so in some ways I look at it as an opportunity where I can go in and I can be like, cool, I'm going to do something completely different, and I'm going to broaden my skill set, and I'm going to, see what some other people have done that's super cool. So, thank you.
The previous companies you come from, what sort of work do junior programmers
So at companies that have been so far, what work do junior programmers usually get? I think that varies. It depends. So I think your odds of doing fun work is better at a smaller company if you're a junior, but it's also harder to get hired as a junior programmer at a smaller company because they have less bandwidth to mentor you. So it's kind of a trade-off. And so, some places it's been like, this person does documentation, which is not exciting. But then, for example, at Uber Entertainment, when we hire junior people, it was like, here's the system, you go figure that out. We'll assume that you're good enough to do this. And we'll mentor and we'll be there for people, but like, that's your ownership, and so you get like whole swaths of stuff. So it's a really broad range, and just kind of, I think it's an important question to ask when you're interviewing. Like what can I expect to be doing here? How much responsibility will I be given? Because you're just as much as interviewing them as they're interviewing you, and so you got to figure out if you'll be happy there.
Any more questions? All right.
What's your favorite color?
Purple.
He's got the coolest coat. Anyway, thank him.